For most hydrology analysis, it is important to know the areal distribution of precipitation. Usually, average depths for representative portions of the watershed are determined and used for this purpose. The most direct approach is to use the arithmetic average of gauge quantities. This procedure is satisfactory if gauges are uniformly distributed and the topography is flat. Other commonly used methods are the isohydral method and the Thiessen method. The reliability of rainfall measured at one gauge in representing the average depth over a surrounding area is a function of the distance from the gauge to the center of the representative area, the size of the area, topography, the nature of the rainfall of concern, and local storm pattern characteristics. The arithmetic average method uses only those gauging stations within the topographic basin and is calculated using these equations. So P equals to summation of Pi over N. The Pi is the precipitation depth at gauge I within the topographic basin, and N is the total number of gauging stations. Another method for calculating average precipitation is the Thiessen method. This technique has the advantage of being quick to apply for multiple storms because it uses fixed sub-areas. It is based on the hypothesis that for every point in the area, the best estimate of rainfall is the measurement physically closest to the point. This concept is implemented by drawing perpendicular bisectors to straight lines connecting each two rain gauges. This procedure is not suitable for mountainous areas because of orographic influences. The procedure involves first connecting each precipitation station with straight lines, and then constructing perpendicular bisectors of the connecting lines and forming polygons with these bisectors. These are the polygons formed here. So there are 1, 2, 3, 4, 5, and 6 polygons. And then the area of the polygon is determined. So the average precipitation is equals to the summation of polygon area for each station, multiplied with the precipitation and divided by summation of total polygon area. Example 2.6. Using data given below, estimate the average precipitation using Thiessen method. All the informations are given in this table: the stations from A to J, the areas, and the precipitation values. Using Thiessen method, first we have to multiply the area with the precipitation for each station. To get the average precipitation, this value is divided by summation of area. So 69,210 divided by 568 is equals to 121.8 millimeters. The isohydral method is based on interpolation between gauges. It closely resembles the calculation of contours in surveying and mapping. The first step in developing an isohydral map is to plot the rain gauge locations on a suitable map and to record the rainfall amounts. So here in this figure, if you can see, there are 1, 2, 3, 4, 5, 6, 7, and 8 rainfall stations with the rainfall amounts. Next, an interpolation between gauges is performed and rainfall amounts at selected increments are plotted, so they are increasing. Identical depths from each interpolation are then connected to form isohyads or lines of equal rain depths. The areal average is the weighted average of depths between these isohyads, that is the mean value between these two lines. This is the equation used to compute using the isohydral method. P, or mean areal precipitation, is equals to precipitation depth for each station multiply with the area and divided by the summation of the area. This is the equation used to calculate the mean areal rainfall using isohydrology method. P, which is mean areal precipitation, equals to average of precipitation depth for each station, multiply with the area and divided by the summation of the area. Example 2.7. Use the isohydrology method to determine the average precipitation depth within the basin for the storm. So first determine what contours of equal precipitation or isohydrology you will use. This varies from situation to situation, but you want to have as many contours as necessary to get an accurate model, but not so many that your construction becomes cluttered. In this example, I used the following isohydrologies: 10, 20, 30, 40, 50, 60, and 70. Draw the isohydrologies of various values by considering the point rainfall data as guidelines and interpolating between them. Determine the area between each pair of the isohydrologies lines. So all these informations I put in this table: the isohydrological interval, the average precipitation, and the area. Then multiply the area between each contour by the average precipitation in the area to get the rainfall volume. Sum these volumes to get the total rainfall volume. Then divide it by the area of the watershed to get the average areal precipitation. For this example, the average precipitation is equals to 39.3 centimeters.
So thank you. I hope you enjoy this course.